Hi guys, today's video is the kind of intro lesson to our new unit, which is statistics. Statistics is the analysis of sets of data, which you can collect through surveying, measurement, and experiments. Sometimes it's given to you, which will usually be the case for us. And we want to analyze it in different ways. The first idea is to try to come up with one number, one measurement that represents a group of data. So for instance, suppose we had, I don't know, suppose these are test scores, 80, and I'll put them in order, 90, 91. So just a small class of 4. What were their test scores? And the question is, how do I come up with one number that best represents these 4 scores? This is something you're familiar with because the usual kind of measurement we do for test scores is what we call the mean. You may also call it the average. And you add them all up and you divide by the total number. And this gives you some number, you hope that's roughly in the center of your data. There's 2 notations for this. Sometimes we use this formula where if you have data points x1, x2, x3, and x4, so n here in this formula is the last number of your data points. You add them all up and you divide by the number there is. And we use a little x with a bar over it. Or sometimes we use, this is the Greek letter mu, to represent our mean. And we usually use mu if our data represents an entire population. So if you survey every student at UCC for their height, you would know the average of the entire school confidently. But that's a lot of work. So sometimes you just want to take a sample measurement. Which means, okay, well, maybe I'll survey 20 students in year 1, 20 students in year 2, 20 students in FY, 20 students in IV1, and 20 students in IV2. And it's a lot easier than surveying every single student. And if you're smart about how you sample, hopefully the average of the sample will be pretty close to the true average. So that's just a little bit of vocabulary you have to know. Sample, population. Now the median is another statistic you're no doubt familiar with. The median, let's suppose we had these following marks, 70, 71, 73, 99, and let's put a low one on the end, 60. The median is the data point that lies in the middle. So in this case, it would be 71. And this is very good for outliers, if you have outliers in your data set. And we'll talk more about that in a moment. The third one you may have heard of before, the third way to represent a set of data by one number, is the mode. And the mode is the most frequently occurring value in a data set. Suppose I had this data set, 1, 1, 2, 3. 3, the mode would be 1. If I added another 3 on, now there are 2 modes, 1 or 3. If every number is equally occurring, as in this data set, there is no mode. And now the question that hopefully is coming to your mind is, when should I use a given statistic to represent my data? When should I use the mean? When should I use the median? And when should I use the mode? Well, the mean, if there are no outliers, an outlier is a 1 data point or 2 data points that are way different from most of them. And we'll talk more about how to determine if something is an outlier, but for now, just use your common sense. Mean is a great stat if there are no outliers. Every higher numbers weigh more on the mean, and lower numbers weigh less, and you end up getting a number that really is kind of weighted in the middle. The median is a great alternative if there are outliers. because say I had, I don't know, these class marks. Now this 99 at the end, that would affect the mean quite a bit, right? Because that 99 is pulling up the mean. But really, what number? I would say 60 or 61, that really, really represents this data well. Almost everyone got that score. So if I do the median, I see, oh, it's actually 61. That's in the middle. So median is a good choice if there are some really high or really low numbers. Now, what about the mode? Well, the mode doesn't really seem that useful. Just because something occurs a lot doesn't mean it represents your data very well. Consider this data set. Let's say some number in the 60s or close to the 60s would probably represent this data set the best, but the mode is 2, which is probably the least representative number of this data set. So you might wonder, when is the mode really what you want? Now, consider this problem. Find the mode of this data set. Now these aren't numbers, so of course we can't do mean or we can't do median, but you can easily imagine a survey where you asked a bunch of students what their favorite fruit was, and how do you pick the fruit that best represented that data set? Well, I would say the mode would tell you apple. Apple is the best. This type of data is called qualitative data, and the mode is good for qualitative data because you can't average them or take the median. The numbers you see from the previous examples are called a quantitative data, as they represent quantities. The last thing I should mention before we move on is, suppose we wanted to find the median of this, say this data set. Well, there's no number in the middle, right? The middle of this data set is kind of here, between 2 and 3. And to do that, if you have 2 numbers in the middle, you just average them, go halfway between them. So the median of this data set would be 2.5. Now, you need to know how to handle large data sets. Like, even consider this very basic example in front of you about a bunch of students' final grades. It's kind of annoying to type them on your calculator. You'd have to order them if you wanted to find the median. If you can imagine a very large data set, it might not be obvious what the mode is, certainly. So you need to watch the video. I'm going to post a video of how to do this on your GDC, on your TI Nspire. So watch the video. It's posted with this video on Haiku under lesson notes statistics. Okay, so watch that video. You can pause this, open that in a new tab if you like, and go on, but it's very, very important. The statistics unit is basically a calculator-based unit. And if you don't know how to use your calculator for this unit, you will suffer. The next very important concept is that of a frequency table. So let's look at this table. This is a bunch of data. It's a group of adults. They were surveyed for their number of children. This is a typo here. And so you see some have 2 children, some have 1, some have 4, a couple have 0. And this is really inefficient. Like, most people kind of have one of the same few answers. So we can organize this data into a frequency table. What does this mean? Okay, some people have 0 children. How many of them? 1, 2. 2. Their frequency is 2. Some people have 1 child. How many of them? 1, 2, 3, 4, 5, 6. Their frequency is 6. So this is a more compact way of writing a table with a lot of recurring data. So this is called a frequency table. Now, how would we calculate mean, median, mode? Suppose we were just given this frequency table. We don't know the kind of expanded version. Well, the mean, remember the mean, let's call it x bar. That is, you add them all up and you divide by the total number. Okay, so I have 2 entries of 0, so 2 times 0 plus 6 entries of 1 plus 3 entries of 2 plus 3 entries of 3 plus 2 entries of 4. Now what's the total number? Well, I can add up the frequencies. 2 plus 6 is 8, plus 3 is 11, plus 3 is 14, plus 2 is 16. And let's see what we get here. 6 plus 6 plus 9 plus 8, 16, which is 12 plus 9 is 21, plus 8 is 29 over 16 is your average. Maybe I made a careless error there, but you get the picture. Now, the median, how do we get the median? Well, these are in order, right? We have, think of this frequency table of really being a list: 0, 0, 1, 1, 1, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4. So there are 16 entries. So the median entry is going to be between the 8th and the 9th. So the 8th entry is a 1, because we have 2 zeros and 6 ones. And the 9th entry is a 2. So it's going to be halfway between 1 and 2, which of course is 1.5. And the mode is very quick. The mode is whatever has the highest frequency, which in this case is 1. Okay, so you see here, our mean, median, and mode, they're all somewhere between 1 and less than 2. So they all kind of match up. The last concept from this lesson is called grouping of data. So again, let's consider this survey. This is a survey of the distance each student in the class lives from ECC in kilometers. So this guy lives 8.72 kilometers away. This guy lives 250 meters away, 4.55, you see. And sometimes you don't really care about the exact distances, just kind of how many people live, say, here within 1 kilometer, how many people live between 1 and 2, how many people live between 2 and 3. You might imagine another example where you want to know how many students got 7s, how many students got 6s, how many got 5s, etc. So we go through how many students live between 0 and 1 kilometers. 1, 2, just 2. 2. How many students live between 1 and 2 kilometers? 1, 2, 3. 3 students. Okay, 2 to 3, we've got 1, 2, 3, 4, 5, 6. And I notice that I missed one of the 1 students, so I'm going to change my last one to 4. Now, how many live between 3 and 4? 1. Just 1. And I notice again I missed a 2 to 3. So I'm going to change my last one to a 7. 4 to 5. Let's see. 1, 2. 5 to 6. 1, 2. 6 to 7, 1. 7 to 8, none. And there's 1 between 8 and 9. And you can check to see if you've done this correctly by adding up the frequencies and making sure it matches your data. So we have 6, 13, 14, 16, 18, 19, 20. And here we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So they match. So chances are I got them all. Now, how do we calculate the mean, median, and mode here? Because these two say between 0 and 1, we don't really know if they're, say we were just given this table with group data. We don't really know if they're a 0.1 and a 0.9 or two 0.5s. So what we do is we make our best guess. So when we calculate with the mean, median, and mode, we assume every number between 0 and 1 is halfway through the interval, 0.5. These are all 1.5s, these are all 2.5, and so on. Now I would recommend, you've already watched the video, hopefully by now, about how to use your graphing calculator to calculate mean, median, mode easily. So you can now enter a frequency table with this list as your data set and these as your frequencies. Or of course, you could, still do, it's like the mean is 2 times 0.5 plus 4 times 1.5 and blah, 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 all the way through. So this is called grouping of data. So we group our data between 0 and 1, 1 and 2, 2 and 3. You can use any grouping you want. I could have done 0 to 4, 5 to 8, etc. So for homework, do the worksheet provided. Now, since I'm not here, obviously, I'll have to wait until next day to answer any questions you have, but do your very best. Thanks.